Hey everyone, welcome back to my YouTube channel. Today we are going to solve this problem, that is count complete tree nodes. So in this problem we have a function called count nodes. Okay, we have a function called count nodes that takes a tree node called root as its input. Okay, so first we are going to check if the root is empty, that is null. So if our root is empty, in that case it means that we have reached the end of the tree, so we return 0. So this is our base case. Okay, so here write if root is equal to null, then we are going to return 0. So this is our base case. Okay, so as we go through this code, I will do my best to keep it simple and easy to grasp. However, if you want an even more in-depth look at the recursion and how this code works, so I have created a separate tutorial just for that. So you can find the link for that video in the description below. So feel free to watch that tutorial after this one for a more detailed breakdown of how this recursion works in this problem. So it's a great way to reinforce your understanding of recursion and take your coding skills to the next level. Alright, so let's continue with our exploration of this fascinating piece of code. So now first we check that if our root is null, then we are going to return 0. After that, if root is not empty, then we will do the following. First we are going to count the number of nodes in the left subtree by calling count nodes root.left. Okay, count nodes root.left, and we store this count in the variable left node. Okay, so I am going to create one variable int left node. I am storing that value here. Okay, left node is equal to count nodes root.left. Okay, now in the same way we count the number of nodes in the right subtree by calling count nodes root.right. So we store this count in the variable right node. Okay, so int right node is equal to count nodes root dot left root dot right. Okay, then finally we return the sum of left node, right node and 1. Okay, return left node plus right node plus 1. So this one represents the current node we are on. Okay, so we add the count of nodes on the left, count of nodes on the right and 1 for the current node to get the total count of nodes in the tree. Okay, so here let's say in this example, so first we are going to move to the left node of 1, that is 2, then we will move to the left node of 2, that is 4. So for 4 we are going to get the count of left node, which is 0. Okay, 0 is a left node, then we are going to check the right node 0, and then we count the value of this 4, that is left node, right node plus this node value, so total 1. So this one will move to the 2. Same way for 5 we will get the count 1, so this one will move here. So for 2 we get the count as 1 of this, 1 of this and 1 of this 2, total 3, and this 3 will move to the 1. Okay, and here same way this one will move to here, from here we will move to, so in the for the one node, for root node 1, left node's count is 3, right node count is 2, and then in the end we are going to add this 3, this 2 and plus 1, so we are going to get output as 6. Okay, so that's it. So this code uses a recursive approach, okay, to traverse the binary tree and count all the nodes. So it keeps breaking the problem into smaller parts until it reaches the base case. Okay, that is an empty tree, and then it adds up the count to find the total number of nodes in the tree. Okay, so I hope that this helps you understand how this code works. So if you have any questions, feel free to ask. Okay, now let me try to run it. So all the test cases have passed. Now let me submit it. Okay, so our solution is accepted with runtime of it beats around 100% of users with Java. Okay, so before we wrap up, I want to encourage all of you to explore more about coding and computer science. So if you find this explanation helpful and want to learn more, consider subscribing to my YouTube channel. I regularly share tutorials and content that can help you on your coding journey. So don't hesitate. Click subscribe button and join our coding community. So happy coding, and I will see you in the next video. Thank you.